Hi everybody. We are starting a new unit, and this is the first lesson of that unit, Unit 5. And this unit is a lot about math. It's moles and stoichiometry and empirical formulas, percent comp. So it's basically a mathematical unit. We will start our first lesson on moles, and that mole is to discuss the mole, we need to understand the concept of dozen. But in general, mole is a unit. You need to understand that mole is a unit. Just like dozen is a unit, or grams, or milliliters, or liters are units. And but scientists wanted to count atoms. So let's say you have 12.01 grams of carbon. They wanted to see that if I take 12.01 grams of carbon, how many atoms of carbon are there. Okay, they wanted to count the atoms of carbon. Okay, so scientists wanted to count the atoms of carbon, and they could use the dozen, like dozen has 12 atoms, okay, or a dozen bananas have 12 bananas, or dozen of schools have 12 schools. But same thing, they could have, okay, 1 dozen of carbon will be 12 carbon atoms. But the problem with the dozen is that the atom is so small that 1 dozen is not enough for me to do anything with, or even to be able to see it. So they say, okay, 100 dozen, 1,000 dozens, a million dozens. It is still not big of a number for us to hold it, to work with, or to have a proper count of. So that's why they could not use the dozen. So there was a scientist, his name was Avogadro. He introduced another counting unit, okay, another counting unit. And he said, okay, if I have 1 mole, all right, if I have 1 mole, then 1 mole will have this many atoms in it. So you can imagine that why a dozen does not work. Okay, 1 dozen only have 12. So there is no comparison. And it is because atoms and molecules are so small that we cannot use this small of a number. So that's also a reason you understand why the scientific notation is so important, that 1 mole is equal to 6.02 times 10 to the 23 atoms. Okay, but the rest of the story is the same. Like 1 dozen of students, teachers, bananas, eggs, elephants, no matter what I say, the number is 12. So please remember that no matter what we say, it can be the student, teachers, paper clips, schools, atoms, molecules, okay, formula units. No matter what I say, or paper clips, no matter what I say, the number is not going to change. Okay, so you have to memorize this number, that 1 mole is equal to 6.02 times 10 to the 23, could be atoms, could be molecules, could be formula units for ionic compounds. For ionic compounds use formula units, and covalent compounds use molecules, and for elements we use atoms. So also keep that in mind. So for covalent compounds it's molecules, for ionic compounds it's formula units, and for elements it's atoms. But the number does not change, the number stays the same. So let's go back to what we were doing before. The 1 mole is a unit, it's a quantity similar to the idea of dozen. Okay, 1 dozen is 12, 1 gross is 12 dozens, or 1 mole is this number. So 1 mole of anything is equal to this number. That is the bottom line that we learned as of now. Mole is a unit. Avogadro, we call it Avogadro number because Avogadro was a scientist who gave us this number. A cube would have to have 40 kilometers sides to hold this many grains of sand. Okay, so this is giving you a concept of how big the number is. Okay, so if you take a cube and you want to fill it with the sand, you need 40 kilometers. All right, 40 kilometers big of a cube to fill it with this many sand grains. So if you count the sand grains inside it, then it will be this many sand grains. 1 mole of pennies, like pennies and quarters and nickels, so pennies would make at least 7 stacks that would each reach the moon. So 1 stack can reach the moon. Okay, 1 stack of 1 mole of pennies can reach the moon, and you can make 7 round trips, 7 trips of that. So this is just giving you a concept of how big the number is. There are approximately this many milliliters of the water in the Pacific Ocean. Milliliters. Can you imagine how big the milliliter is? You know, so it's this many milliliters of water in Pacific Ocean. So 1 mole of donuts holes would cover the entire surface of the earth 5 miles deep. So just imagine how big or huge this number is. Okay. Let's move on. So if we understand what a mole is, and 1 mole is equal to that number, and 1 mole is equal to a huge number. Okay, keep this in mind. We are going to calculate a unit factor to use dimensional analysis. Okay, so let's say if I want to find out that how many, 1 mole of carbon, 1 mole of carbon equals to 6.02 times 10 to the 23 atoms, then how many atoms are in 2.7 moles of carbon? Okay, first of all, I need to know that 1 mole of carbon is this many atoms. Okay, then 2.7 moles is how many atoms? So I have 2.7 moles right here, the same dimensional analysis method. I draw a big plus sign. Okay, on that big plus sign, I write my question here that I have 2.7 moles. 2.7 moles. Now I have to match the unit. If mole is here, then from this equation I need to take mole, which is 1 mole. Mole will always be 1. 1 mole, and then equals to 6.02 times 10 to the 23 atoms. And all I am doing is my moles get cancelled. I multiply these two numbers. Okay, and that is my answer. Okay, I get 16 times 10 to the 23. When I multiply the two together, I need 2 significant digit answer. I have 2 significant digits here, 3 significant digits here. So I need a 2 significant digit answer. And then I move my decimal point 1 space to the left. That makes it 1.6 times 10 to the 24 atoms. So let's go ahead and do this. Then how many moles of iron 3 chloride? Iron 3 chloride is FeCl3. How many moles of iron 3 chloride are in this many formula units? So why am I using formula units instead of atoms? Because carbon was an element, so I used atoms. Now iron 3 chloride is an ionic compound. Whenever I have ionic compounds, I use formula units. Okay, so the process is not going to change. The process is the same. That I will draw a big plus sign. Okay, I draw the big plus sign. I write my question here. Okay, let me do it again. I draw a big plus sign. This is what I'm given in the question right here, 2.75 times 10 to the 25 formula units. Now I know that 1 mole is equal to how many formula units? 2.75 times 10 to the, I'm sorry, I'm not paying attention. Where is my eraser? 1 mole is equal to how many formula units? 6.02 times 10 to the 23 formula units. So this is my conversion factor. Okay, now out of this conversion factor, I need to see which unit matches this unit, and this is where you have a problem. When you're like, okay, I don't know, Ms. Kumar, when to multiply, when to divide. Well, you have to write the unit first, and if you're lazy and not writing the unit, then of course you don't know which one to multiply and which one to divide. So you have to write the unit here. Once you have the unit, you have to match the unit from your conversion factor. Of course, mole does not match with formula unit, so I cannot write a mole here. This side of the equation matches my unit. So I will say 6.02 times 10 to the 23 formula unit equals to 1 mole. Okay, so once I do that, my formula units get cancelled, okay, because it's the same unit, and 25 minus 23, so that takes care of this part. I don't plug this into the calculator. 25 minus 23 is 10 to the power 2. Okay, now I am going to divide the two numbers. Okay, when I divide the two numbers, it's I have 3 significant digits here, 3 significant digits here. My answer is going to be 0.457. I have 10 to the power 2, so I move my decimal point to here, and that gives me 45.7 moles. Okay, it's 3 significant digits, and this is how you do it. So you have to know your conversion factor, that 1 mole is equal to this number, and then either you will be multiplying it or you will be dividing it. So it's one or the other that you're doing. Next thing, we also, let's do another one, determine the example. Example page 311. So you go to the book on page 311. I have 2.50 moles of zinc. So I write whatever I am given in the question, 2.50 moles. It's asking you to calculate the number of atoms. Well, first of all, I need to know that 1 mole is equal to how many atoms? 1 mole is equal to 6.02 times 10 to the 23 atoms. Okay, now which part of the conversion factor matches my given? Mole matches my unit right here. So 1 mole comes here and the other side goes here. 23 atoms. This is deciding that you are going to multiply them together. So you multiply the two together, your answer should be in 3 significant digits, and you put your answer right here, and 10 to the 23 goes with your answer. Okay, let's do one more and then I'm done with this part. There I have 5.75 times 10 to the 24 atoms. Now 1 mole is equal to how many atoms? Well, I hope you have memorized it by now, because if you are listening to it this many times, you should have memorized it. 1 mole is always equal to this many atoms. Now, which part of the equation matches it? This part matches it. So 6.02 times 10 to the 23. 6.02 times 10 to the 23 atoms equals to 1 mole. So atoms get cancelled. 24 minus 23. This is 23 right here. When you are dividing, the exponents get subtracted. Okay, so 24 minus 23 is 10 to the power 1. And then you divide the two numbers. You have 3 significant digits here, 3 here. So the answer should be 3 significant digits, and your answer will be in moles. So the unit here will be moles. So these are the examples that I did from the book. So you need to pay attention to this and do some practice. So we will do the practice in the class. These are the questions that is not your homework, because your homework is to listen to the lectures. So it is a classwork, not the homework anymore. As I said that homework is only listening to the lectures. So let's move on. The next thing we want to talk about is that 1 mole is equal to the molar mass. Okay, or maybe I can do that in the next video. Hold on. Alright, so let's go ahead and take notes on molar mass as well. 1 mole is equal to the molar mass of any element that you get from the periodic table. So if you go to the periodic table and we get the molar masses from the periodic table, let's say that the mass of carbon is 12.01 grams, the mass of hydrogen is 1.01 grams, mass of nitrogen is 14.00 grams, oxygen is 16.00 grams. So whatever you're getting from the periodic table is equal to 1 mole. So this whole thing is equal to 1 mole. Okay, 1 mole of carbon is equal to 12.01 grams. And where do you get this from? The periodic table. 1 mole of nitrogen, 1 mole of nitrogen is equal to 14.01 grams, which you get from the periodic table. 1 mole of oxygen is equal to 16.00 grams, again gotten from the periodic table. And we also learned that that 1 mole equals to also 6.02 times 10 to the 23 atoms. Okay, so 1 mole is equal to this many grams and this many atoms. 1 mole is equal to this many grams and this many molecules. I'm sorry, atoms. Okay, 1 mole is equal to this many grams and this many atoms. What about water? 1 mole of water. Do we know how to calculate the molar mass? Where we add all the masses together, multiply by 2 and 16, multiplied by 1, so it's 18.01 grams. Okay, you added all the masses together. It is also equal to this many molecules. So do you see that this number does not change? Okay, so 1 mole of NaCl. NaCl is an ionic compound. So 1 mole of NaCl, I know sodium is 23 point something, chlorine is 35. I'm just doing it off of my head. So it's 58 point some grams that I got from the periodic table, equals to again this many formula units. So please and please and please pay attention that I can change the element. Okay, I can change it to a compound. Okay, I have the elements here and I have the compounds here. With changing the element, what is changing? The masses are changing, right? All of this is changing because I'm getting this from the periodic table. Every element has a different mass. But what stays the same? This number stays the same. So no matter what is I have here, I have elements, I have compounds, covalent compounds, ionic compounds, doesn't matter. Nothing, this number does not change. Okay, the units may change, atoms or molecules with formula units, but the number doesn't change. But when it comes to mass, okay, the mass that I get from the periodic table would of course change. So calculate the mass in grams of this many moles of chromium. Okay, chromium. So I have what I'm given is the moles. I'm given is the moles, and 1 mole of chromium is this many grams that I get from the periodic table. So I put moles here and grams go here. So what are you given? That goes here, the molar mass, and the units go here. You multiply them together. You multiply them together. Moles get cancelled. Your answer will be in grams. Okay. In class, practice these questions. You need to practice 316 and do 11AB and 12AB and 318. So this is something you are going to do in the class, and these are the answers for that classwork. So this is how you convert grams into moles and moles into grams. Okay. But it has nothing to do with Avogadro's number. The Avogadro's number stays the same, but that is a different concept. Next, what if I have to do two-step? Like I have 52 grams of lithium into atoms. So if I have 52 grams of lithium into atoms, maybe I use a different color. What am I given? I'm given 55.2 grams of lithium. Okay, I know that if I go to the periodic table, 1 mole of lithium is equal to 6.94 grams. And I also know that 1 mole of lithium is equal to how many atoms of lithium? 6.02 times 10 to the 23 atoms of lithium. Okay, so I have grams here. These are my two conversion factors. All right, I'm given grams in the question. The question is asking me to go to the atoms. So first of all, I need to match with this unit. Okay, this part matches with this unit. The atoms and moles don't match with the unit. So I will say, okay, 6.94 grams is 1 mole. Okay, because the other part goes up in the denominator. And then now I need to use the other conversion factor. Now which part matches the other conversion factor? I have mole here, so mole matches it. So 1 mole is equal to 6.02 times 10 to the 23 atoms. Okay. If I can cancel it, my grams get cancelled, my moles get cancelled. The only unit left is atoms. I multiply this with 1, I multiply this with 6.02, and I divide by this. Or you can divide and then multiply, doesn't really matter. But basically you multiply all across and you divide by the numbers in the denominator, and your answer is going to be 4.79 times 10 to the 24 atoms. So here is another example of it. Okay, so after you do these 2 or 3 examples, like let's say you have 6.02 times 10 to the 24 atoms. So I start with my atoms. I know that this many atoms equals to 1 mole, and then 1 mole equals to this many. This number is coming from the periodic table. So since I was given, this was given in the question, I was given this, and I start with my given, and then I know this many atoms equals to 1 mole, and then 1 mole equals to the grams, and then you multiply all across, divide by the numbers in the denominator. Third example, you are given again grams, so you start with grams, then you go to the periodic table, get the molar mass. Okay, this information is coming from the periodic table, equals to 1 mole, and then 1 mole equals to this many formula units. And then it's asking for a sample of aluminum chloride has a mass of this. How many aluminum ions are there? Remember, we dissociated. It will dissociate into what? 1 aluminum ion and 3 chloride ions, right? So in 1 formula unit of aluminum chloride gives you 1 aluminum ion. All right. If it had asked you about chloride ions, okay, then what would you have done? You would have had 3 chloride ions here. Okay, so we will do more practice in the class. See, it's asking you the same thing. We will do this practice in the class, page number 326, and these 3 questions. And that's all in this video. So we learned about mole and how mole is related to atoms and formula units. Okay, and how mole is related to the molar mass in the periodic table. This information comes from the periodic table. This is atoms, molecules, and formula units. So it's all about it. And this is molar mass that you get from the periodic table. Thank you very much for your attention. I'll see you in the class.